Hi everyone. Today I would like to present to all of you about our experiment 2. And the title of our experiment is Electrical Fields and Potential in the Plate Capacitor. Here I want to introduce our group member first. Firstly, my name is Mustaqim bin Kamaruzaman and my metric number is 228951.
Hello, good evening everyone. My name is Muhammad Safiuddin bin Khairul Azman. Metric number 230651.
Assalamualaikum and good evening everyone. My name is Umar Al Farouk bin Sukiran. My metric number is 229160.
Hi, today I will explain an introduction part. Principle. A uniform electric field E is produced between the change plates of a plate capacitor. The strength of the field is determined with the electric field strength meter as a function of the plate spacing D and the voltage U. The potential within the field is measured with a potential measuring probe. Theory. Follow from Maxwell's equations for the electric field E in the plate's capacitor for the steady state case in the charge free subs between the plates. If one plate is placed in the YZ plane and the other parallel to it at a distance D, and if boundary disturbance due to the finite extent of the plates are disregarded, it follows from 2 that E lies in the x direction and is uniform. Since the field is irrotational, rod E equals to 0, it can be represented as the gradient of a scalar field. While E, because of its uniformity, may also be expressed as the quotient of differences, where the potential difference is equal to the applied voltage U and D is the distance between the plates. Since the potential of an equipotential surface in the plate capacitor is linearly dependent on its distance x, for example, from the plate with potential.
So, I want to present to all of you about the experimental results. From table 1, the plate spacing is set to be 10 centimeter, and we are doing the experiment about the plate voltage UV and the electric field strength E in the unit of kilovolt per meter. From this table, what I can say is when the plate voltage is increasing, the electric field strength value will be also increasing. So this relationship is directly proportional. So here is the result of our experiment is about the graph of electric field strength E, kilovolt per meter, and against plate voltage U in the unit of voltage. So here is what I can say is the graph is increasing because when the plate voltage is increased, the electric field strength is also increasing. So in the table 2, the experiment is about the plate spacing D in the unit of centimeter and the electric field strength E in the unit of kilovolt per meter. So from table 2, the voltage is set to be 200 volt. And what I can say from this table, when the plate spacing D in the unit of centimeter is increasing, the electric field strength E in the unit of kilovolt per meter will be decreasing. So the relationship between these two factors is inversely proportional. So here is the graph of our experimental result. So firstly is about the graph electric field strength E in the unit of the kilovolt per meter against the plate spacing D in the unit of centimeter. So from our experiment in the lab, what I can say, we are just setting the value of the plate spacing D, and the result of the manipulated value we are get in the electric field strength. So the manipulated variable is about the plate spacing, and the responsive variable is about the electric field strength E in the unit of kilovolt per meter. So the next one is graph log E against log D. So as you can see, as all of you can see, is a decreasing graph. So log D will be the manipulative variable, and the graph log E will be the responsive variable. So for our final experiment, we are discussing about the probe position X in the unit of centimeter and the potential between the plates in the unit of voltage. So from the experiment, the plate spacing is set to be 10 centimeter and the applied voltage is set to be 250 volt. So from this table, when the probe position is increasing, the potential between the plate will be decreasing. So this relationship is inversely proportional. So from this graph, it is about the graph potential between the plates V and against probe position X centimeter. So from this graph is when we are changing the probe position, it should be the manipulative variable. And the result of the manipulative variable should be the responsive variable. And the responsive variable for our experiment is potential between the plate in the unit of voltage. So from this graph is a decreasing graph. So here is about the calculation from our experiment. We are using the E equal to V divided by R, where V in the unit of voltage and the R in the unit of meter. So there are eight set of value that we just need to substitute the value, and we are just need to find the electric field in the unit of voltage per meter. So from the table in the experiment, from table 3, we are just substitute the value and we are just getting the electric field value. So don't forget the unit of the electric field is volt meter of negative power of -1.
So now I would like to share our discussion from this experiment. The result that we got in this experiment is not very accurate because of some reasons such as error from the material that we use. Not only that, it is also affect the graph that we did in this experiment. Some of the value that we take from the data cannot fully fit the best fit line on the graph. Next, we can say about our what we can say about our experiment is that the experiment had some error, such as the observational error about our experiment. Because the electric field strength cannot be static and it is so difficult to take the most accurate value. We already tried our best to take the best value from the material that we use. Next, we uh, we also tried to manage the data enough to make sure that we are able to do the graph. From the experiment, we can observe relationship between voltage and electric field with constant plate spacing, the relationship between electric field strength and plate spacing with the constant voltage. We are also able to measure the potential in plate capacitor as a function of position. Finally, our conclusion, it is confirmed from table 1. The plate spacing is set to be 10 centimeter when the plate voltage U in unit of V is increased. The value of electric field strength E unit kilovolt per meter will also increase. For example, when the plate voltage is set to 100 volt, the electric field strength is 13.15 kilovolt per meter. And when the plate voltage is set to 120 volt, the electric field strength is increased to 13.6 kilometer per volt, kilovolt per meter. Sorry. Thus, the plate voltage is directly proportional to electric field strength E. Next, from table 2, the voltage is 200 volt. When the plate spacing D in centimeter is increased, the electric field strength E kilovolt per meter is decreased. Thus, this relationship is called inversely proportional. Next, the relationship between log D and the end log E is also inversely proportional. Lastly, from table 3, when the probe position X in centimeter is increased, the potential between plates V will decrease. From this experiment, we can conclude that our experiment is a success.
So I think that's all from our group members. So I hope all of you can understand and have a knowledge about our experiment. So thank you everyone. Have a good day. Bye.
Thank you, everyone.